Suppose a plus b plus c equals to pi. Show that cosine of angle A plus cosine of angle B minus cosine of angle C, that's equals to -1 plus 4 times the product of cosine of the half angle A over 2 times cosine of the half angle B over 2 times sine of the half angle C over 2. Now this is a problem of conditional trigonometric identity. Now let's try to understand what it means when we say it's in a conditional trig identity. So let's consider the identity sine squared theta plus cosine squared theta equals to 1. Now this is an identity. That's because this equation is going to be true for any values of theta that we choose. But for our case, the given trigonometric equation, or you can say trigonometric identity, it's going to be true for specific values of a, b and c. Now the values of a, b and c must be such that their sum equals pi radian. Okay, let us begin. So here what we'll do, we'll start from the left hand side and then we will show that exactly equals to the expression on the right hand side. So on the left hand side we have cosine of angle A added to cosine of angle B minus cosine of angle C. So what we will do here, we're going to combine the first two terms. Now we have a standard formula for adding the two cosine functions, so that's given by 2 times cosine of the angle A plus B divided by 2 multiplied to cosine of the angle A minus B divided by 2 minus the second term, which is cosine of C. Okay, now here we can work with this angle A plus B over 2. So we'll be using the fact that A plus B plus C, that's equals to pi. Now what we'll do, we'll keep A plus B on the left hand side, but we will transpose C to the right hand side, and that's going to give us pi minus C. Now let's divide both sides with 2. So that we get A plus B divided by 2, and on the right hand side we have pi over 2 minus C over 2. Now what we'll do, we're going to take the cosine on both sides. So if we take the cosine on both sides, we get cosine of A plus B divided by 2. This is going to be equals to cosine of the angle pi over 2 minus C over 2. Now what is cosine of pi over 2 minus some angle theta? Now that's given by sine of that angle theta. Now in our case, theta is simply C over 2. In other words, what we're saying here is that cosine of the angle A plus B over 2, this is the same as sine of C over 2. So let's use this. We're going to get 2 times. So in place of cosine of A plus B over 2, we're going to replace it with sine C over 2 multiplied to cosine of A minus B over 2. Then we have negative cosine C. Now if we look at the expression on the right hand side, we need a -1 here. Okay, to make it -1, so what we'll do, we're going to use a half angle formula which is already defined for cosine theta. So let's say if we have the cosine theta, so this is given by 1 minus 2 times sine squared theta over 2. Now in our case, theta is represented by the angle C. So that means if we replace cosine C with the half angle formula, we're going to get -1. So we have negative multiplied to 1 minus 2. So we have -1 added to 2 times sine squared C over 2. So we can observe here that we have obtained this -1, which we need on the right hand side. So we'll keep it as it is. We'll make it the first term -1. Now what we'll do, we'll consider the first term and the third term in the previous step, and we can see that from each of the two terms we can take 2 times cosine of C over 2 as the common factor. So let's pull out 2 times sine C over 2 as the common factor. So that means this is going to get multiplied to cosine of the angle A minus B over 2. Then we have added to it sine C over 2. Okay, now what we'll do here, we're going to work with sine C over 2. So let's first write down all the other terms. We have -1 added to 2 times sine of the angle C over 2. So this is going to get multiplied to cosine of the angle A minus B over 2. Now sine C over 2. So here Again, we use the given condition, that means a plus b plus c, that's equals to pi, but we can represent c as pi minus a plus b. So if we divide both sides with 2, we're going to get c over 2 equals to pi over 2 minus a plus b over 2. Now what we'll do, since we need sine c over 2, we are going to take the sine on both sides. So we get sine of c over 2. And on the right hand side, we have sine of pi over 2 minus a plus b over 2. That's simply going to become cosine of the angle a plus b over 2. So what we'll do here, so in place of sine c over 2, we're going to replace it with positive cosine of the angle a plus b over 2. Now why we have done this? This is done because now, as we can see inside the parentheses, we have the sum of two cosine function. So we have a standard formula for adding two cosine function that's going to give us the product of two cosine functions. Now let's do this. We have negative 1. Let's do one thing. Let me note down the formula that we'll be using here. So the formula that we'll be using here is if we have cosine of angle C added to the cosine of angle D, this is simply going to be equals to 2 times cosine of the angle C plus D over 2 multiplied to cosine of the angle C minus D over 2. Now we'll consider a plus b over 2 to be equivalent to c and a minus b over 2 to be equivalent to d. If we apply this formula, now what we will get here is, so we already have a 2 here, so this 2 comes here, and we have multiplied to it sine c over 2 multiplied to 2 times, so we are going to take cosine of, so we need c plus d over 2. Now when we add c and d, that's going to give us a. Now we have a, but we also have division by 2, so we get cosine of a over 2, and the other one, cosine of c minus d over 2, that's going to give us b over 2. So now what we get is negative 1 added to, so this factor 2 and this factor 2 multiplies to give us 4. So we have 4 times cosine of the angle a over 2 multiplied to cosine of the angle b over 2 times sine of the angle c over 2, and this is the expression on the right hand side. So here we have successfully showed that, hence, well, we can say, hence, if we have cosine of the angle A added to cosine of the angle B minus cosine of the angle C, then this is going to be equals to negative 1 added to 4 times cosine of the half angle A over 2 multiplied to cosine of the half angle P over 2 times sine of the half angle C over 2, and this is going to be true for the with the condition that A plus B plus C, the sum of the angles of the triangle, must be equals to pi radians, hence proved.